All right, so let's continue on the diesel cycle for sample problem number 3. Here we are given compression ratio, so 18.2, and then temperature 1. Okay, so temperature 1, 27. So converting it to Kelvin right away. So this is 300 Kelvin. And then pressure 1 as 100 kilopascal. And temperature 3, 1700 Kelvin. Okay, so letter A, cut-off ratio. So let's solve for cut-off ratio. Cut-off ratio is, okay, so R sub C is the ratio between volume 3 and volume 2. And this is also equivalent to temperature 3, the ratio between temperature 3 and temperature 2. Okay, so uh, we don't have volume 3 and we can't solve for volume 2. So we are now left with this relationship, temperature 3 and temperature 2. So for temperature 2, can we solve for temperature 2? Okay, so yes, we can solve for temperature 2. And temperature 2 is temperature 1 multiplied by compression ratio raised to K minus 1. So once you solve for temperature 2, we are now ready to solve for R sub C. Or we can use right away this relationship wherein temperature 3 is temperature 1 multiplied by R to the K minus 1 multiplied by R sub C. And from here, okay, so from here, temperature 3 is given as 1700. Then this is 300. Then R is 18.2 raised to 1.4 minus 1. And then we are now left with R sub C. So solving for R sub C is 1.77. So that answers letter A. How about letter B? So letter B is heat rejection per unit mass. Okay, so heat rejection per unit mass. So heat rejection, formula for heat rejection is Q. Then heat rejection occurs at constant volume process. Then temperature 4 minus temperature 1. Okay. Okay, so no problem with this one. This is constant, so 0.718. How about temperature 1? This is given. And temperature 4, this is not given, but we can solve for temperature 4. So for temperature 4, okay, so for temperature 4, this is temperature 1, R sub C to the K. And this is, so 300 multiplied by 1.77 raised to 1.4. And temperature 4 is 667.24 Kelvin. And this time we will be expressing heat energy per unit mass. So this is 0.718, then 667.24 minus 300. And this gives us 263.67 kilojoules per kilogram. Next is thermal efficiency. So this is the third question. Is 1 minus 1 over compression ratio raised to K minus 1. And this is multiplied to, so this is K, then R sub C minus 1. And this is R sub C to the K minus 1. And thermal efficiency, so we already have these values. This is 1 over 18.2 raised to 1.4 minus 1, 1.4, then 1.77 minus 1, 1.77 raised to 1.4, then minus 1, and thermal efficiency is 0.6442. And that answers all the question for this problem. Okay? And don't forget to like and subscribe. Yeah. All right.
What's up? Slap us. Slap like now. Slap the like button now. Don't worry, I'm not forcing you.